All right, let's continue our unit on solving equations and inequalities, and let's get into the solving inequalities portion of the unit. We've mastered solving an equation, and we'll apply that same process to inequalities. Inequalities, we'll learn what they are, and we'll see that the process of solving those is very similar to solving equations. So let's get started with that. Okay, so first of all, let's take a look at what an inequality is and what it means. This first one, we have x is less than 5. Okay, this symbol means less than. Okay, this one means less than or equal to. It's got the line under it. We've got greater than and greater than or equal to. And that's how we read those as we come across them. We talked about those in our earlier units. I just wanted to review that for you. Okay, so now as we take a look at this first one, how do we represent it on a number line? What does it mean? If I say x is less than 5, what are some values that I could have? Well, you might say 4 is less than 5, 3 is, 2 is, 1, 0. Okay, all these integers are less than 5. You would say, well, 5 isn't less than 5. Neither is 6 or 7 or 8 or 9 or 10. So we kind of start to see a divide here. But how do we signify that on the number line? Okay. Well, if I want to represent all real numbers less than 5, well, I could have 4.9 or 4.999. How close can I get? All the way up until I get 5. So the way we represent that, we know, well, it's got to be all these values. And those go on forever. But to show that 5 is that dividing point, we'll have an empty circle there to show that at 5, it's not a solution, but anything less than 5 works. Okay, we can do the same thing with x is less or equal to negative, or x is less than or equal to 5. Well, 5 is less than or equal to 5, so is 4, 3, and so on. These numbers are not less than or equal to. So now 5 can be included, so since that's one of the solutions, we'll just leave that with a closed dot. And so it's similar in that way. So when we have less than or equal to or greater than or equal to, we signify where that point is with a dot, because that's the equal point. And then whichever way the solutions are, we draw a line on the number line showing all the solutions. If it's just less than or greater than, we use an empty circle to show that at that point it's not equal. Okay, so now that we've got the definition of an inequality and how to represent it on a number line, let's take a look at how to start solving these. We're going to use the addition property of inequality, subtraction property of inequality, multiplication property of inequality, and division property of inequality. These properties you want to put into your notebook, but these properties are similar to the addition property of the properties of equality. Just a little difference in there that we want to take note of. We'll put the algebra in here and the words in here in just a moment, but let's just talk about what this means first of all. So let's just say that we've got a value, okay? And let's say we've got 6 is greater than 4. Okay, we agree that that's true. Let's add a number to both sides. Let's add the same value. Let's add 2 to both sides. 8 is now greater than 6. That's still true. Nothing changes. So this inequality, nothing changes. We still have an equivalent inequality. Okay? Nothing has changed. We know the number on the left is still greater. Okay? Let's now subtract 3 from both sides. So what happens when we subtract something from both sides? I get 5 and I get 3. I know 5 is still greater than 3. The left side is still greater. So nothing changes when we subtract something from both sides. Okay? Let's take a look at when we multiply something. Times 2 on both sides. 10 and 6. 10 is still greater than 6. Nothing has changed. Let's now divide by both sides. Divide on both sides. Divide by 2, divide by 2. I've got 5 and 3. 5 is still greater. So nothing changes when I divide by a positive integer. Okay? Well, let's see what happens if we were to do the same thing with a negative value. So let's start with 6 and 4. Let's say add a negative 2 to both sides. Well, that's the same as subtracting, so nothing's going to change. So I get 4 and 2. Okay? Still the same. Let's say I subtract a negative. Subtract negative 3. That's the same as adding, so nothing's going to change there either. Okay? Now, let's multiply by a negative. So multiply by negative 2. Multiply by negative 2 over here. That's negative 14, and this is negative 10. Now I know that negative 14 is less than negative 14. So you can see that when I multiply by a negative, that sign flips around. And let's do the same thing by dividing. If I divide by negative 2 on both sides, I get 7 and positive 5. 7 is now greater than 5. And that sign got reversed again. So we'll keep that in mind. So we'll put that in writing that you can write down in your notes. But know that the addition and subtraction properties of inequality, the sign stays. When we multiply and divide by a positive, it stays. When we multiply and divide, the multiplication and division properties of inequality state that that sign is going to flip around. Okay? Okay, so what we just did, we can now put down in words in an algebra. You can write down the definition of those properties, and here's what it means in algebra. Basically, what that says is if one number is greater than the other, then if we add the same number to both sides, it's still greater. Nothing happens to the sign. So those are all the examples that are listed there. You can pause the video and copy both those properties into your notes. And when you're ready, start it up again. Okay, so let's apply those properties with solving and graphing the solutions. So if we're solving for y, 6 is greater than y minus 3.3. I'm going to add 3.3 to both sides. And I get 9.3 is greater than y. Okay? So I know at 9.3, the values I can have solutions either greater than 9.3 or less than 9.3. I've just got to figure out where the solutions are. But I know that the solutions are not equal to 9.3. So I know I'm going to have an empty circle. I just got to figure out where the solutions lie. So choose a test point. Okay? Choose a value either in front of 9.3 or after it. So I can compare. Is 9.3 greater than 9? Yes, it is. So that is a solution. If I tried with 10, is 9.3 greater than 10? No, it is not. So that is not a solution. So once I see what side of the point the solutions are on, I can draw an arrow to indicate where all the solutions lie. Second example, 3 plus m is greater or equal to 7.2. Solving for m, so I subtract 3 from both sides. M is greater or equal to 4.2. So I know the values can be equal at 4.2. Here's 4.2. So choose a test point. Try 4. Okay. And the value is 4 greater or equal to 4.2. No, it is not. So I can try with another value, with 5. Is 5 greater than or equal to 4.2? Yes, that is a solution. So I know all the solutions will be on that side of the line. Okay. Let's take a look at the multiplication property of inequality. Once again, you can copy down those notes, pause the video, but keep in mind these are all the examples that we have here. We're just saying that if we multiply by a positive number, it doesn't change the inequality at all. Okay, that's what this first and third example show. If we multiply by a negative number, it's going to end up flipping the sign if we multiply both sides by that same negative number. Okay, to keep that inequality true. Same goes true with the equal, less or equal to, or greater or equal to. Okay, so here we've got y divided by 9 is greater than 3, so multiply both sides by 9. So y is greater than 27. So I know at 27 it's not equal, but it's our point that determines whether the solutions are greater or less. And y is greater than 27. Let's try 30. Is 30 greater than 27? Yes, it is. So I know the solutions will be on that side. Division property of inequality. Once again, there's the notes. You can put those down. We'll apply it in the solution down below. Negative 4x is less than 36. So in order to get x by itself, I divide by negative 4. X is now 36 divided by negative 4 is negative 9. But in order to keep this as a true inequality, since I divided both sides by a negative, the rule says when we divide both sides by a negative, we need to reverse the inequality. So now I'm going to say it's greater than negative 9. Okay, so that's important to remember. When you multiply or divide both sides by a negative, you need to flip that inequality around. So at negative 9 is our dividing point. Solutions are either to the right or the left, greater or less. In order to figure it out, we can try a test point. Try negative 8. Is negative 8 greater than negative 9? Yes, it is. So I found the solutions. I don't need to try the other side. Okay? So those are the basics of solving inequalities. We have to know those rules before we can do anything else and get into more complex inequalities. So we can do the same thing now if we have a multi-step inequality. Okay, same rules apply for solving equations. Get the x alone on one side. So add or subtract x terms alone on one side. So 4x is greater or equal to, because we added, okay, it doesn't change the sign. And multiply or divide, the answer you will find. So divide by 4, dividing by a positive 4, so the sign stays, so x is greater or equal to 2. So my number line, I'll put some points on, 1, 2, and 3. I know x can be equal to 2. I just need a test. Is 1 greater or equal to 2? No. Is 3 greater or equal to 2? Yes. So 3 is where the solutions are. Draw my arrow there. Okay, why don't you try the next example, pause it, start it up again when you're ready. Okay, in order to get c by itself, I distribute it first. And then I subtract 2 from both sides. Nothing happens to the inequality sign. Divide by negative 2. Since I'm dividing by a negative, that inequality needs to flip. So c is greater than 12. Since it's just greater, I include the empty circle to show where the dividing point is. Then I check my solutions. Is 11 or 13 greater than 12? 13 is. So I'll draw an arrow to the right to show where all the solutions are. Okay, I think you're ready to try and figure these ones out. Multi-step inequalities with variables on both sides. Pause the video, see if you can figure these examples out. Check it when you're ready. Okay, so let's take a look at the first example. I got the m terms alone on one side, so I subtracted 4m from both sides. And then in order to get the m by itself, I added 7 to both sides. 4m is less than 12. And divided by 4, m is less than 3. Notice I divided by a positive, sign stays. And here are all my solutions. Second example, I combined like terms first. And then I added 9 to both sides. 6y is less or equal to 6y minus 7. Subtracted 6y to get the y terms alone. And when I did that, I canceled out all my y terms. So I had nothing less or equal to negative 7. At that point, I look at the inequality. 0 is less than or equal to negative 7. I've lost my variable. And just like when we're solving equations, I know that that's not a true statement. So when it's not a true statement, we have no solution. If this were a true statement, let's say it said 0 is greater than negative 7. In that case, we would say infinitely many solutions because it's always true. All right, so that's the first part of this. We'll get into solving compound inequalities and what those are in the second video.